Trooper Tide Tuesday. This is actually the 27th of April. We're almost done with this month. Then we're really into our home stretch in May. You guys will be able to use permutations and combinations to find out how many arrangements and groups can be made. Section 12.1. Now, you might notice on Thursday we're going to be map testing. Then the following Monday, we're going to be finishing up this section, okay? So the plan is to start this section today, map test next class, and then finish the section the following class. Does that make sense? Zion?
Is this the entire packet of sections?
No. The entire packet's the chapter. All right. So, first of all, I'm going to put my name, Me llamo Señor Castle, in Espanol. Or in English, my name is Mr. Castle. So write down your name on that if you haven't already. It looks like most of us have, which is good. The first thing we're going to talk about is the fundamental counting principle. What does fundamental mean? What does fundamental mean? Mason, put it away. It's supposed to be fun. Not quite. Mason, have you heard fundamentals anywhere in sports by chance?
I don't know. Honestly, yeah, maybe.
Maybe. Laney, have you ever heard about fundamentals in sports ever?
Oh, yeah.
Okay, what are the fundamentals in sports, usually?
Like the main stuff?
Like the main stuff, right? Like, in baseball, what would you say some fundamentals are?
Throwing a ball.
Okay, throwing a ball, right? Okay, some of the very basic skills to where it's like we often overlook them, but can you play baseball well without being able to throw a ball well? No, you can't, okay? In soccer, one of the fundamental skills would be passing a ball, okay? In volleyball, a fundamental skill would be passing a ball just in a different way than soccer, for example, okay? Or a fundamental thing for anything would just be some basic skill that you need to do everything else. It's like at the core level. Mason, put it in your backpack. And put your mask over your nose, please. So this is the same idea with being a fundamental principle, but this is for counting. Okay? So if decision M, so if some decision that we're just calling M, because it could be any decision. It could be what to wear for the day. It could be what to order at a restaurant. It could be what way to drive to work. Okay? If decision M can be made lowercase m ways, and decision N, another decision, so it could be another one of those what to order, or if I get this for supper, what do I get for dessert, can be made N ways, just some number of ways, then the two decisions together can be made M times N ways. Lainey, please write this down. Thank you. Okay. So here's an example. And this is, in my opinion, a very relevant example to you. Who likes ice cream? If you don't raise your hand, I might kick you out of the class. Not actually, okay? The ice cream shop offers a choice of 3 cone sizes. Okay, so like a small, medium, large kind of idea. 15 flavors, so that's quite a bit. And 8 toppings. That's a wide variety, wouldn't you say? Okay? So, how many cones are possible if you can, how many different combinations of cones can you get if you only choose one flavor and one topping? So you choose one cone, one flavor, one topping. And we'd say, okay, how many options are there? Well, we have 3 different options for cone sizes, right? How many options do we have for flavors? Because we had 3 cone sizes. We had 15 for flavors. And what did we have for toppings? 8. And we're picking one of each of them, right? So you take 3 times 15 times 8. And that would be our answer if we take that. Shay?
What's the answer?
I think I have the answer, but I'm not 100% sure.
Okay, what do you think it is?
I think it's 240.
I think it's a little higher, actually.
2,700.
I think it's lower. I think your calculator was correct there.
Yeah, me too.
Okay? And I'm going to allow us to do a little more calculator work in this chapter than I would have suggested before, okay? This ends up giving us 360 combinations. So if you go to this ice cream shop, they have 3 cone sizes, 15 flavors, and 8 toppings, and you just do one of each, 1 cone size, one flavor, 1 topping, you can get 360 different combinations. You could go every day for almost an entire year, minus 5 days, and get something different.
I'm gonna do that.
That's kind of cool to me. I'm just saying, I mean, that's kind of cool. You don't like realize like, oh my gosh, that's a lot of, like you think like, oh, it's a lot of choices. But you don't realize it's that many choices. The math behind it was we just multiplied how many options of each choice there were.
Did you just make a pun?
I don't think so.
Cool.
Oh, unintentional. I'll take it. Virginia license plates consist of 3 letters followed by 4 digits. A lot of Omaha Lincoln ones, you'll see 3 digits and then and three letters and then 3 digits, right?
I thought it had to be 8.
Can it be all letters?
It depends on the state, okay? So a standard Virginia license plate consists of 3 letters followed by 4 digits. How many different license plates are possible? Now, this is a question that they have to actually ask when they're making the decision of how to do their license plates. This is why they do it like this, because they need to have so many different options. Because if you just had 12 different options, well, you're going to run out of license plates pretty quickly for people, right? Because people can't have the same license plate. Then you wouldn't know whose car is whose. So every single one has to have a different license plate, and they have to be sure they're never going to run out. So it has to be a lot of combinations, right? Because everybody in that state gets one that drives a car there. And some people have multiple cars, right? That's a lot.
Every state has a license.
Every state has license plates, yep. Yeah. So we have 7 different spots here, right? 1, 2, 3 letters, followed by 1, 2, 3, 4 digits, right? We had 3 letters followed by 4 digits. Is that correct? Well, how many letters do you have to choose from for the first spot? 26. There's 26 letters in the alphabet, right? So there's 26 choices for the first letter. Now, if you have a letter in the first part of your license plate, can you still have it again later in your license plate? Yeah, you've probably seen some around like that. So how many options are there for the second letter? 26 again. It's not like, oh, you've already used it, you can't use it again. Okay, well, how many options are there going to be for the third one then? 26. So we're going to have 26 times 26 times 26. We already know that. This is going to get big. Then, 4 digits. Digits are numbers, right? Now, if it's just a 1-digit number, how many of those are there?
9.
Okay, well, think about it, actually. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. Am I missing one? 0. So how many are there actually? There's 10. So there's 10 single-digit numbers. We don't think about 0. So 10 options. Once again, you have 10, 10, and 10. Just like with the letters, if you have a number, you can have it again, and you can have it again, and you can have it again. So we're going to do 26 times 26 times 26 times 10 times 10 times 10 times 10. Holy cow, right? This is going to be a big number.
7 million.
Okay? This ends up being, believe it or not, and you can type it in your calculators. Actually, type it in your calculators. Go ahead and do that. Sure. Pull it out. Or you can grab one from up here. Don't blurt. Don't blurt. Okay, Zyron, pull out your phone.
Holy. 1 million.
Don't blurt. Don't blurt. It's more than that.
I'm kidding. That's why I said 1 million. It's a big number.
It is.
Too big. That's one money I make a day, you know.
Oh, totally. Okay.
I wish.
What does the number end up being? Anyone want to tell me what they ended up getting here?
175.
175,760,000.
Yeah. 175,760,000 different combinations. That's a lot.
That's enough. That's easy paycheck day.
Easy paycheck. That's how many different license plates that you could have in the state of Virginia.
Wait. That's a lot.
That is a lot.
That's too much.
So we can figure out like Omaha and Lincoln's because they do the same system. 3 letters, 3 numbers, right? So that'd be the same idea, but with 1 less 10, right? Well, if you multiply by 10, you just add a 0 on. Do you guys know that fact? So Omaha and Lincoln's, just those 2 cities
Not as big.
would be 17,576,000 possibles. And there's way less people than that in Omaha and Lincoln. That's how they can account for everything.
No way there's that much in Omaha.
No, there's way more people than that. So, or excuse me, that's way more than the people in Omaha and Lincoln. So that way, they have plenty of combinations. They're not going to run out for a long, long time.
That's a lot.
So they built themselves a lot of wiggle room, didn't they?
Almost the entire human race
Too much.
goes into one.
Yeah, right?
Honestly, Virginia's not that big. Like, you think about it, there's not much people out there.
All right. So, number 3. Nick's science test has a section with 12 true or false questions. How many different ways can Nick answer these questions? Well, you have 12 questions. In each question, you can answer how many ways? 2. Either what or what? True or false. So the first question, you have 2 options. How many do you have for the second question? 2 options. How many do you have for the third true or false questions? 2 options. Are we noticing a theme? So how many 2s are we going to have multiplying together here? 12. 12 different 2s. 5, 6, 7, 8, 9, 10, 11, 12. Now that's the same thing as saying 2 to what power? 12. That's just saying 12 2s. So you can type that in your calculator, or you can do 2 times 2 times 2 times 2 times 2. And this will tell us how many different ways Nick could answer on his 12 true or false questions. Nope. 2 to the power of 12 is not the same as 2 times 12.
Oh.
It's way more than 24. I'll tell you that. Way more. 4,096 different ways.
Dear Lord.
That was 6,000.
4,096 different options.
These are like huge numbers.
These are. So if you're just randomly guessing on these and you have no idea on them, you have a 1 in 4,096 of a chance. Is that very big odds to get all of them right? Now you have better odds than that to get at least one of them right. But that would be your odds of getting 100% on this test of 12 true or false questions if you had no idea what you did, if you just blindly guess.
If you think about it, I feel like I would take forever just to put those numbers in. Like, it would have taken 5 minutes.
Yeah.
I would second guess myself so much.
I'd be like, oh, did I put 2? Oh.
All right. To enter their home, the Clayton family enters a 4-digit code. Anyone have like a code like that in the garage or something?
Yeah.
Okay, some of us do. Okay, anyone seen that?
I have a 3-digit.
Okay, so we could do the same type of problem with a 3-digit code, right? Okay, or a 4-digit. Okay, you have a 3-digit code?
Yeah.
Let's switch it to a 3-digit code. That's what Aiden said he has. Let's try that. Okay, so cross it out. We'll do a 3-digit code here. Same idea. Now, if it's digits, how many? What kind of things are we talking about? Numbers, right? And how many options are there for the first digit? 10, 0 through 9. Okay. How many options for the second one? 10. You can use the same one twice, right? Your code could be like 777. Okay, how many for the third option? 10. So, Aiden, you would have 10 times 10 times 10, which is also the same as 10 to the third, right?
Wait, I'm a little confused.
100. 200.
1,000.
1,000.
1,000.
7,000.
1,000.
Honestly, think about
Aiden's family has 1,000 different possible combinations to their lock. So if somebody was trying to break into their house, they'd have to sit there and try 1,000 different combinations to make sure they got it right.
But it can be more, couldn't it?
Not for 3 digits. That's the maximum possible. If they tried 1,000 different combinations like 111, 112, 113, 114, 115, like go through everything like that, you get 1,000 different combinations. So eventually, if you did 1,000 of them, you get it. You might get it on your first one. You might get it on your third one. You might get it on your 50th. You might get it on your 800th. You might get it on your 1,000th. You don't know. Miss Haswell?
We're doing 3 instead of 4?
Yeah, we switched it to 3 because Aiden said he has a 3-digit code at his house.
Okay.
So we just said, let's try 3. See what 8? See how we could break into Aiden's house.
4-digit would be 10,000.
4-digit would be 10,000. So notice even adding one more digit makes the odds way worse to try and guess it.
I would try it.
You try it. You just sit there punching 1,000 different combinations to break it into his house. That'd take a while too.
It would take longer than a day.
Okay. Any question, Maddie? Did you end up?
Yeah,
Ma-
I needed to.
I don't know why someone would break
Imagine
into
a
a house.
12-digit combination.
Okay. Let's go over 12 digits. That'd be even more, right? Okay. Factorials are the next concept we're going to cover. Factorial. It looks like this in the box. N exclamation. Have you guys ever seen exclamation in math before?
No.
Okay. Maybe not on like a standardized test even.
No.
Okay. Well, we're going to learn about it now. It's called factorial. Factorial. Factorial is defined as, lady, please write this down, the product, so multiplication, of all natural numbers from n to 1. From whatever n is all the way down to 1. Now, natural numbers, if we remember back to way at the beginning of the year, are numbers that we see in nature. So do you see halves of things in nature, really? Like, do you see, like, half a tree naturally?
Yeah.
Not really.
No.
I mean, yeah.
Not standard. Okay? We don't normally see half a thing. Oh, I'm going to go pick half an apple. Okay, I'm going to go grab half a blade of grass. No, it's a full blade of grass. Now, you can change it and cut it in half, but naturally, it is a full blade, right? You can cut the apple in half, but naturally, it's a full apple.
Some things.
Now, do we see even 0 in nature? No, you can't see it if it's not there. Because 0 means it's not there, so you can't see it. So natural numbers are like 1, 2, 3, 4. They're the numbers we count with. Just like when you start counting, you don't say 0, 1, 2, 3. Like, I don't go like when I'm walking, I'm like 0, 1, 2. Like, that'd be weird. I just go 1, 2, 3, 4, however many steps. So, and you go a countdown all the way through. So an example here, 9 factorial would be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So 9 factorial means, it's a shorthand way of writing it. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Would you guys want to write this out all the time? No, that's why this is made. So that way, we know that's what it means. It means this number all the way down to 1. All of them multiplying together. So if you type this into a calculator, and there's actually a way on a scientific calculator, you can just type in 9 factorial, and it does it for you, so you don't have to type in 9 times 8 times... blah, blah, blah. What do we end up getting?
362,800.
That's exactly right. 800 and... just 800, I believe.
That thing.
I think it's just...
880.
Oh, is it 880? Okay, you're right. You're right, my bad. I must have copied that down wrong. I must have had it wrong.
I have the exclamation mark. Yes, I have the easy way.
There you go. Android calculators are better than iPhone calculators by far, actually. Spoken as someone with an iPhone, Android calculators, way better. So 12 factorial, 12 times 11 times 10 times 9. Aiden, what do you get for 12 factorial, since you have the calculator?
12 factorial is 479 million.
How do we do the
1,600.
Very good. Well said. Okay. 8 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Aiden?
8 factorial. 40,320.
Okay. Now notice, 8 factorial to 9 factorial is 9 factorial. It's only one more number, but isn't it like a lot bigger? Yeah. It's a lot bigger, okay? Because you took this already big number and multiplied it by 9.
It was 328 and 321.
320. 320. We could also do division with this. So you could do like 17 factorial divided by 11 factorial. We'll actually end up doing that in a little bit here. And I'll have us start putting these in calculators actually for this to make our life easier. So in my calculator, which is a TI-30X, if you look up at the top above the screen, it says what type of calculator. I want us to test it with 8 factorial real quick, okay? So type in 8. Type in 8, okay? Then if you go to the very top left, you see the second button, right? Don't push it, but do you see the second button at the very top left?
Yeah.
I pushed it.
Okay, push it again if you pushed it. Okay, if you pushed it once, push it twice. Otherwise, don't push it. Now, if you go diagonal from there, do you see a button that says PRB?
Yeah.
What do you think it might stand for? Any guesses?
Product.
PRB. It's an abbreviation. Or is the first part of a word. Probability. Is that what we're going over? Probability?
Sure.
Okay, so hit that PRB button, the probability button. And what do you see as the third option there?
N.
The third option.
R.
Nope. So NPR is the first option.
It's the extra
Oh.
product.
It's the factorial.
Oh. Who?
The factorial is the third option. So move your arrows. Yep, on your top right, move the arrows twice to the right, and you land on the factorial button. So hit enter.
Oh.
Okay, let me help you out in a moment then. So do you get 8 factorial, 8 exclamation?
Yeah.
Okay, push enter. And you should get the same thing. Do you get it?
Yeah.
Okay, perfect.
Oh.
Did anybody not get this? If you did not get this, let me help you right now.
Can I try it on my phone?
Zarin, try it on here so that way when you come to the test, you can do it. You can try it on your phone. I'm not sure if the iPhone has it. I don't think it does.
0 is 1, guys. 0 is 1.
What?
0 is 1.
So this next part will be very tough to do on an iPhone calculator, even though the iPhone does have a factorial button. Now, what we're going to want to do is 17 factorial divided by 11 factorial. On an iPhone, you'd probably want to type in 17 factorial, enter, write it down. Type in 11 factorial, enter, write it down, and then do the top divided by the bottom.
Whoa.
On these scientific calculators, here's what you can do. Parenthesis. So do a parentheses right above the 8 button. Right above the 8 button, hit parentheses. Do 17 factorial. So go to 17, probability, factorial, end your parenthesis. Divide. And do the same thing on the bottom, parenthesis 11 factorial.
Do I have to do that on my?
Wait, what? Do what?
I have to do the parentheses.
So technically it should work without it, but for other stuff we're going to do, it's going to be helpful
What is
for us
it?
to start doing it.
How do we do that?
8, 9, 1,
So-
0, 7, 2, 0.
Type it in like this, buddy. So 17 factorial divided by 11 factorial. And parentheses, yep. Divided.
Divided?
Yep, because that's the problem we're doing.
Yeah, it came out the same both ways that I do it.
Mm-hmm. Okay? And if we do this correctly, we should end up getting this massive number, which is 8,910,720.
Oh, I can
Yes. But stuff we're going to do later, you're going to want to get used to that calculator, Aiden. Okay? Questions on that? Okay? 0 factorial, if you type that in your calculator, Mason actually shared, it's
1.
1.
How's it 1 though? Like,
Kind of a weird one, right? That's really weird that it is 1. Well, 0's not a natural number like we talked about earlier. So we just say that 0 factorial is 1 just for a rule of thumb, saying, hey, how many ways do you have 0 things? So that's what factorial is used for, is how many ways something can be arranged. Okay? And you just say, well, how many arrays can you have 0 things? There's one way to have 0 things, you just have 0 things. It's the same with having one thing, you just have it. That make sense? Okay, great question. Okay. We are actually going to stop there in our notes for today. And then we're going to pick up with permutations and combinations next time.
can I put like holes in these things?
Please and thank you. Over to the side here. I want you for now to do, once again, we're going to keep that same kind of pattern we've been doing part, then I'll Mason mask up. Okay. I'm going to have you do 1 through 9.
14.
I'm going to have you do the first 9. We should confidently be able to do the first 9, I would say.
10 as a bonus.
If you want to try 10, feel free. I'm not going to assign 10 yet. If you want to try 10, feel free.